Hello, I'm Professor Sunche Kim, Department of Biomedical Engineering, Yeomyung University. In this study, a sheet was made using Eggshell and Bismuth oxide, a new radiation shielding material, and the shielding performance was tested. Recently, a lot of research has been done on the development of shielding suits to protect against indirect scattering radiation generated in medical institutions. Existing shielding clothes use a shielding sheet mixed with the shielding material and rubber as a lining. Due to the nature of the shielding clothing that must be worn all the time, the shielding sheet should be made lightweight. Also, in recent years, various studies on the development of eco-friendly shielding materials are being conducted due to environmental pollution issues. In this study, a shielding sheet was fabricated using bismuth oxide, a low-dose shielding material, and eggshell powder, a household waste. Eggshell is a household waste made of 96% calcium carbonate, and economical efficiency can be expected when used as a radiation shielding material. These materials will be fused with bismuth oxide, which has been used as an existing shielding material to improve the insufficient shielding performance. The eggshell consists of 96% calcium carbonate, and although the shielding performance is insufficient, it is expected that the shielding performance will be improved when mixed with other shielding materials. In addition, bismuth oxide has a density of about 8 to 9 and is already widely known as an eco-friendly shielding material. Currently, research on the radiation shielding performance of eggshell is in its infancy, and research to improve the shielding performance through fusion with other materials rather than independent forms is being conducted. In addition, a study to increase the radiation shielding effect by mixing it with the mortar used as a concrete recycling material has also been reported. Therefore, it is expected that research to develop various shielding materials and process methods that can be mixed with eggshells is required in the future. First, the eggshell was washed with distilled water to remove impurities and then dried at a temperature of 25 to 30 degrees Celsius. The dried eggshells were made into powder form using a blender and then filtered through a micron sieve. Next, it was mixed with bismuth oxide in a ratio of 5 to 5 through a ball milling machine. In addition, high-density polyethylene, or polymer material, was mixed to prepare the mixed shielding material in the form of a sheet. The sheet was finally manufactured by calendar process, which is a compression molding process. The size was 150 mm square and the thickness was 1 mm. The composition of the radiation shielding test of the fabricated sheet is as follows. In order to test the shielding performance of the manufactured sheet, the lead equivalent test method of the Korean industry standard was applied. In addition, the tube voltage when measuring shielding performance was set sequentially from low energy to high energy used in medical institutions. It was measured using an X-ray generator and a dose detector, and the shielding efficiency was calculated through the equation after the measurement. The exterior and cross-sectional views of the manufactured shielding sheet are as follows. As shown in the photo, the particle distribution was dense, and it can be confirmed that the eggshell powder affects the particle dispersion and density in the sheet. Such a dense distribution can be expected to improve the radiation shielding performance by improving the density. For such a dense structure, it is important to select a polymer material or shielding material that has good compatibility with the eggshell. The shielding performance results are as follows. The fabricated sheet showed a shielding efficiency of 70% in the low dose region and 50% in the high energy region. Therefore, the shielding performance was found to be more effective in the low dose area than in the high energy area. As a result, it is expected that shielding sheets manufactured in medical institutions that are mainly exposed to indirect scattering and low doses will be usefully used. In this study, a lightweight shielding sheet for the purpose of protecting against low doses generated in medical institutions was attempted. The sheets made using bismuth, oxide, and eggshell powder showed 70% shielding performance in the low dose area and 50% in the high energy area. Therefore, it can be expected to be useful for the protection of scattered radiation, which is indirect radiation that is frequently generated in medical institutions. In addition, it is expected to be eco-friendly as well as economical by using eggshells, which are raised as a new radiation shielding material. However, since there are not many studies on the radiation shielding performance of eggshells, it is judged that research on the development of various shielding materials and processing methods is necessary in the future. Thanks for listening my presentation.